For us today in our lesson, we're going to learn how to do the stats on this stuff. So this is also called a bell curve. Oops, I don't want it in red. I want it to be pretty blue. Bell curve, because it kind of looks like a bell. So this is our bell curve, and it's always symmetrical. Fancy word. Oh, geez. I've been away for too long. Symmetrical. About the mean. So, speaking of that, the mean, which is this lovely symbol, is right in the middle. So, the middle of this is the mean, or the average. So, this is a way of standardizing data so that the middle is the mean. Do you guys remember what symmetrical means? The same. So, what it means is there's 50% of the curve is on this side, and 50% of the curve is on the other side. So there's exactly half on both. So the total area under the curve always equals 1, or 100%. So whether we're talking about, you guys remember decimal percentages? Like probabilities, they usually are written as decimals. So the area under this corresponds to probability. In other words, where is this data likely to be found? So half the data is below the mean and half the data is above the mean. And so how much of the curve tells you where you are in the probability data. Okay. Total probability, which I already wrote, is 100%, because probability has to be 100%. So everywhere under here has to add up to 100, or 1 if we're using decimals. So this is fun because it never touches the x-axis. It goes out and gets really close down to infinity. It's how curves work, but we can still do areas because math. The shape is determined by standard deviation. The good news is that we're not going to be doing calculating standard deviation in today's lesson. We'll mostly be given a standard deviation and then work with it from there. We won't be given a huge set of data and then finding that. The data is given, and then we're going to work with it. So, in this case, I have two different bell curves. Which one do you think has the bigger standard deviation? So, of these two curves, which one has a bigger standard deviation?
The one on the right. Yeah.
It is not this one. It's this one. This is the bigger standard deviation. Remember, what's our one symbol for standard deviation? You guys remember that from the other lesson? Yeah, the symbol that looks kind of like that.
Yeah.
Is bigger. And this one, the sigma, is smaller. Yeah. So that's our, remember, standard deviation, which is this sigma symbol, right? This little circle with a little line on top of it, that means standard deviation. Because standard deviation is a really big word and I don't want to write it. I want to write the one Greek letter that's like that. And that's basically because of the spacings. So since it's all widened out, standard deviation is a measurement of how far away from the mean you are. And so when it's spread out more, you're farther away from your center. Bigger standard deviation. Okay. All right. Now I get to indicate to you guys what a z-score is. Z-scores are what I've given you on this lovely chart of numbers. This is your z-score table. You will get lovely and familiar with it and hate it in the same way. So a z-score, basically all these numbers on the outside. So on the outside is your z. You can see z's up in the corner like this. All the numbers down here and across are your z-scores. In the middle of this thing is probability numbers or percent numbers. So z-scores are on the outside, percents are on the inside. And one side of the sheet is all the numbers, let me just say, less than 50%, and all the numbers on the other side are above 50%. If you look in the middle, it starts at 0, 0, 0 and comes up almost to 5 at the bottom. And then on the other side, it goes from 5 up to almost 1. So that's the way up that way. So that's our z-score table. Now, what do these all represent? A z-score is how many deviations from the mean. So along the bottom of this, these are z-scores. So all these numbers are z-scores. So what we have here is 68% of the population is within 1 standard deviation of the mean. So all of this space in here is 68%. So all the space in here is 68%. So between 1 standard deviation above and 1 standard deviation below, that's 68% of this whole shape is in there. 95% of the population is within 2 standard deviations. So if we go 2 standard deviations away, we get 95% along here. So all the green plus all the blue ones, or this little teal ones at least, that's now 95%. And 99% is within 3. So within 3, you basically have everything. So that's everything. Got nice and colored in there. That looks pretty good. So the z-scores that you're writing are all here, right? What's the biggest z-score I have on this thing? It'll be like 3.5. So at the bottom there, it's like 3.4. And on top of this side, it's negative 3.4. Any more than that, you're getting more than 4 zeros in there. Like, you're getting way out here. And as you say, how much area is out here? Like, essentially none. All the area is in the middle. So that's what all the z-scores mean. That's how all this works. It's a whole thing. So I'm going to pause here. The z-score table, this z-score thing here, is a measurement of all the probability to the left of the z-score. So what I mean to say is it's shown on your z-score, but if I draw a very bad looking bell here, it means that everything to this side. So when we do the z-score tables, it's measuring all the way up to that point. So it's always measuring the left side up to that point, which is why the z-score table starts at basically 0 and goes up to 1, right? All the z-score probabilities go from 0 to 1. In other words, from none to all. So let's put a label on all the things that are in here. This X is our data point. In other words, our reference to the data. And this is our standardization formula. We know what this lovely symbol is. What's this part of our formula? That's mean, or the center. And then the bottom symbol, standard deviation. So what we're going to do now is just try to get used to our z-score tables and use them. They're a bit weird because they're a double-sided table to work with decimal points. It's a little bit tricky, but once we learn how, we can get good at it. So make sure you got your table beside you, and we're going to figure this out. So what we're going to do is find these scores on the table. So first up, we're going to find 1.2 0.21 on the table. So how I'm going to do that? I look for the z-scores. Is 1.21 a positive number or a negative number? Positive numbers. So we're actually looking at the second side. And so the z columns here on the one side are all positive numbers. So we're on the technically back side of it. And we go down. But notice there's not 1.21 on the corner, right? We just have the first numbers, 1.2. So go down here until you get to 1.2. And then the numbers across are that second decimal point. So if I go 1.2 and then 1, it should be 8665. 0.8665. On to the next one. Find negative 1.21 on the table. Oh, excellent. I know. So, same thing, negative. So we're flipping back to the other side of the table. I want you to try to find it. Find it and write it down. The negative matching one. Try it. Okay, it's 0.1131. Between means subtract. Right, when I want between two numbers, I want to subtract. That's like a difference. So because I said between, I'm going to subtract. So I'm going to subtract these numbers here in my calculator. And I get 0.8869 minus 0.1131. Gets me 0.7738. Or, that's it, just it. That's it, just leave it. Undo. Just it. Choop, choop. Done. It should just be 2.36. So find 0.3, then over to the 6. So 0.3 over to 6 for me. I get 0.6406. So make sure you're looking through the table. So on the negative side of the z-score table sheet, I'm looking for minus 1.0, and then over 3s, I get 0.1515. For what we're going to do, since we have a between means subtract, because it's between. So I want to find 2.18 and 1.63, and then I'm going to subtract those two numbers. Right? And then that's going to be my answer. I walked around, most of you got it. Let me just finish writing it in. I want 0.98. Oh, geez, did I get it wrong? Okay, so 218 is 2.1. Oh, it's 2854, yeah. 9854 and 1.63. 9484. There's 0.9484. That's an 8 there. Altogether 0.037. So that's my answer there. Now we can use a mean and a standard deviation separate from the z-scores and apply them to another set of data that doesn't have the mean being 0. So this has my mean being 3 and my standard deviation being 9. I want to use the formula that's on the top of your page. So I want to find out my two z-scores. So I want to find z of the first number and the z of the second number. Now, z's are easy in this way because it's just the formula as written. We don't have to rearrange everything. So the z of the first one is, the formula is x minus mu over standard deviation, right? And for the first number, x is 2. The mu is 3. and the standard deviation is 9. So the first step in the math is to just get this number first. I get 2, subtract 3 over 9. Now this turns out to be negative 0.1111. It's all the ones. But I'm stopping at 4 because the table only has 4 decimals, right? So there's no reason to go past that. That's already plenty. So now what I'm going to do is I'm going to use the table and find out what this probability number is. So now that we have our z-score, we can now use the table like we were doing before. We just have one extra step to get to the z-scores. So now we're going to use it like I gave you the numbers up here. So just find that on the table, minus 0.11 there. So minus 1.111. Yeah, we're negative, right? Yeah, negative. What do I got here? 0, negative 1 point. No, not 1 point, 0.11. There, 0.45. One, yeah. 4, 5, 6, 2. Good. Table, probably. This says use table. For the other x value, it's still x minus mu over standard deviation, which is 10 minus 3 over 9. So we do this number in our calculator and get another decimal. The decimal is 0.78, I think. Let me do it. 10 minus 3 over 9. Yeah. Because I get 7s going down, it has to round up to that 8. Now we will use the table again. It's exactly the same steps as before. I'm going to get positive 7, 8. 0.78. 78.23 it looks like. Great. Now I do have to subtract, so I'm running out of page here, so I'm just going to write subtract these two numbers is how I'm going to get my answer. So this is number, subtract this number, so big minus small, no negatives in my distributions. Record this, 0.3261 is the answer to this question. Yay. Okay, one more for us to do. Okay, one more for us to do, and that's to the right of 14. So that's the x number is going to be 14. So we're going to write z is equal to 14 minus 3 over 9. So that's our math first step. 14 minus 3 over 9. I get 1.22. Now we go table. Uh, 1.22 on the table is 1.22 is all 8s. 0.8888. Great. Then what we'll do is, since it's to the right, I have to go 1 minus, 0.8888 equals 0.1112 as my final answer to this part.